Good evening, guys. So yesterday, I explained covered what are the types of performance testing, and we had some quick assessment on the graphs, right? Explained some. I have shown you some graphs and asked you to identify what graph that test that particular uh, what type of test the graph represents, right? So today let's understand what is the importance of performance testing and what are the prerequisites for performance testing. And I want to cover, if time permits, I want to cover what is application architecture as well. Okay, so let's get started with importance of performance testing. So we already discussed like previously, like suppose if you are using any e-commerce application like Flipkart or Amazon, right? Or any GeoMart, any other e-commerce application, and you are trying to buy a product, and like if your response times are, or if, for that matter, any application, any web application or a mobile app, right? If the response times are high, right? If the response times are high, or once you placed an order, let's say, and you are not getting an order confirmation page as soon as you make the payment, right? So in that case, that there will be an unhappy user experience if your response time is more than 5 seconds for web applications, right? So depends on the application to application, this, by the way. So it can be 3 seconds, 5 seconds, depending on the application. So if the response times are high, obviously, like most users move away to other websites or applications, isn't it? If user has some unhappy experience, right? If user is unhappy with the website performance, those users may be moving to other websites, yes or no? Even if it is a banking website. So I want to give some example here. So previously I used to use like Axis Bank as my salary account, Axis Bank, right? And I face some issues with the website, like whenever I try to do some fund transfer, or whenever like I used to do some payment and all, right? So we, of course, this is the story like 2 years back. This is a 2 years old story. So that net secure code, Axis Bank called that as like net secure code. If someone is using Axis Bank, anyone using Axis Bank here, guys? Net banking, Axis Bank net banking.
Yeah.
Right. So they call it as that, other net banking sites call it as OTP, and they call that as net secure code, right? So that secure code used to, I used to receive very late on my mobile when I'm using, Axis Bank. So of course, like right now, there is a lot of improvement. So this is the, as I said, like this is a 4-year old story, right? So by the time I get that net secure code, right? So, and I enter it, right? So my OTP used to expire. That net secure code used to expire. Again, I have to reinitiate the transaction. So such kind of experience moves you, makes you unhappy with the website. And I stopped using net banking. I switched my salary account to Kotak Mahindra Bank. After after that issue in receiving the net secure code late. Understood, guys? And OTP has some expiry period of 30 seconds. Okay, previously. I don't know how much it is now. And by the time I receive the OTP and enter it, right, it used to say that OTP has expired, net secure code has expired. Right. I had to reinitiate the transaction from the beginning. Right. So with such experience, right? So if your any application, if a user is unhappy with the performance, right, or user is unhappy with the response time of that application, right? So they will move to some other website, isn't it? Or some other application. So due to poor web application performance, right? So it was estimated that there is a $4 to $5 billion revenue loss for any business, right? There used, as per an estimate, there will be $4 to $5 billion revenue loss due to poor web application performance. And inadequate performance can adversely impact the revenue by up to 10% of the company revenue, total company revenue. If the application performance is not good, right, it can impact the company's business, any organization's revenue by 10% as per a research done by Aberdeen. Okay, Aberdeen is a research organization, and which studied the market and came up with these numbers, that the revenue, the overall revenue of the business will be impacted by 10%, right? Which is not a small number. isn't it? And business performance begins to suffer at 5 seconds of delay in web application response time and 4 seconds for critical applications, right? Business performance begins to suffer at 5 seconds of delay in web application response time and 4 seconds for critical applications, right? So, and any additional second of waiting on a website significantly impacts the customer satisfaction and visitor conversions. Any additional second of waiting on a website, it will significantly impact the customer satisfaction and visitor conversions. Clear, guys? I think all these are self-explanatory statements. I need not explain like in detail,
Yes.
isn't it? So page viewers and conversion rate and customer satisfaction drops 11, 7, and 16% respectively if the performance of the application is not good, right? Page viewers, conversion rate means, so initially the first time a user visits a website, right? So we can call him as a visitor. And once he create an account for himself, that we can call that visitor converted into a user, isn't it? So that is conversion rate, guys. And customer satisfaction, all these numbers drop by 11, 7, and 16% respectively. So this is the importance of performance testing. Okay. So I gave one example for that Axis Bank example. So because of which poor performance of their application, right, net banking application, I closed my account with Axis Bank and moved my salary account to Kotak Mahindra Bank, right? And once a business loses a customer, right, it's very difficult to get him back, isn't it?
Yeah, very, very difficult.
Sorry.
Hello.
Yeah, your voice is. Now, what are the prerequisites for doing performance testing? Let's understand what are the prerequisites for doing performance testing. First and foremost prerequisite is a stable build with no major functional defects, right? If the application is not working for single user, right, there is no point in doing performance testing, yes or no? If the application is not working as per the functionality, as per the requirements, right, functional requirements, then there is no point in doing performance testing. So we should have a stable build with no major functional defects. There can be some minor functional defects here and there. You can exclude that particular scenario, but we should not be having any major functional defects for doing performance testing, right? Next important one is performance testing environment should be identical to production environment. The environment in which we are doing performance testing, right? We already discussed that. What is that environment called, guys? What is it?
Test environment.
Let's start. There is one more name, right? What is the other name?
Engineering environment.
Engineering environment, right? So that should be an identical to production environment. Okay. So performance testing environment should be identical to production environment. So then only we'll get accurate results. Okay. What do I mean to say like when identical to production means? Okay. Let me explain that. Suppose you know what is production environment, right? Everyone?
Yes.
Everyone knows what is production environment, right? Production environment means like the live environment, right? So suppose if your production environment has 3 web servers and 4 app servers and 3 database servers, right? So this is a typical architecture of any 3-tier application. This is a typical 3-tier application architecture. When I say architecture, what are the components? How does the request flow? That will be explained, that will be represented in the architecture diagram, right? So let's assume that a production environment has 3 web servers, 4 app servers, and 3 database instances. Servers or instances. We can call that as an instance or a server, right? And your test environment also should be having similar configuration, right? Exactly similar. Means your test environment should be an exact replica of production. Then only you will get accurate results, isn't it?
Yeah.
Right?
Yes.
So that's what I mean to say here, like identical to production environments, right? And to ensure consistent results, there should not be any other testing. Performance testing environment should be isolated from other environments, and no one else should be using that. Such as UAT testing, it should not be used for UAT testing or development and so on. right? To ensure consistent results, performance test environment should be isolated from other environments. There is, such as UAT or development. And no other testing while doing performance test executions. No other testing should be done while doing performance test executions. That is one more prerequisite. And of course, conduct performance testing before the application go live. Right? So it's actually performance testing team who has to certify whether a build should go into production or not. Right? So ideally, performance testing team should certify whether, whenever some new build is deployed or whenever some new code is developed, right? So it's performance testing team who has to certify whether that code or that new build should go into production or not. And that is the reason why performance test engineers are paid at par with the developers, guys. Remember this, right? Even though we don't write much code, right? So we are paid at par with or sometimes more than developers because of this reason. Is the performance testing team like who has to decide whether a new build or new feature should go into production or not. Clear, guys?
Yes.
Yes. But
And next point is like comprehensive understanding and knowledge of the application. Yes. So if you want to do proper performance testing, we should have a comprehensive and complete understanding and knowledge of the application. Right? We should have a thorough knowledge of the application and what are the upstream systems and what are the downstream systems. Right? We'll discuss more on that. What is meant by upstream and downstream system with some examples. So these are the prerequisites for doing performance testing. So important interview questions, guys. What are the prerequisites for doing performance testing? Right? So these are the important prerequisites.
Hi Kishore, can you please come again? Or because just now I called with the manager. That's why I didn't listen.
Mirja.
Yeah.
Okay. Which one you want?
That one, third one. Third, fourth, fifth, sixth.
I'll share the recording. Please go through the recording.
Okay, yeah, please share me recording. That's yesterday's and today's.
Yesterday I already shared. Okay, maybe I
Yeah.
I already uploaded yesterday's session.
Okay.
And if you subscribe to my YouTube channel, you would have got a notification. And please turn on all notifications so that you will get a whenever I upload the video, right? You will get a notification.
Yeah.
Okay. Yeah. So like just by subscribing, you will not get all the notifications, right? You have to turn on all notifications. Right? Please do that, and you would have received that notification.
Yeah.
Yeah. Or else I will share the playlist URL wherein you will have all the list of recorded sessions.
Yeah. Thank you, please.
And this is waterfall model process diagram, right? So waterfall model, of course, waterfall model is obsolete now, outdated now, because everyone is using agile methodology, right? So waterfall model has become obsolete now. So, but it is suitable for very small projects, right? So let's understand, suppose if you want to understand what are the merits of agile methodology. So we should know what are the demerits of a waterfall model, right? So let's understand that. So this is a typical waterfall model process diagram. So which starts with conception or initiation, and requirement analysis will be done here. When I say analysis, requirement analysis will be done here, and then designing phase where the application architecture or application will be designed by the development architect team, right? And construction is nothing but coding, right? So starting the development or developing the application, that is construction phase. So in typical waterfall model process, right? So your testing will start after the code is developed, right? After the development is completed. And this is one of the biggest drawback of this waterfall model, because what is the drawback? Understood, guys? First of all, what is the drawback of waterfall model?
Yeah.
yes.
Advantages.
Testing will be started after the development is completed, right? After development phase is completed, testing will be started. So, however, like what is the disadvantage of that?
Time consuming.
Time consuming, and we can't go back to the previous step as it's already.
Because we have to, if something will happen, we have to go through from top, start from beginning. That one.
Start from the beginning, as we can go to the.
So if any defects are identified, like once the development is completed, right, the cost of fixing the defect will be abnormally high, isn't it? Because all the complete development is done, isn't it? So cost of defect fixing will be high, right? And there will be a total chaos, right? So that is why, like, this has become obsolete. Waterfall model has become obsolete, outdated, and we are following agile methodology, wherein what is the big difference between waterfall and agile methodology?
Basically, agile model will get the build in the like a quarterly wise, and will get the in that agile model. Basically, we have QA team, business analysts, and QA team. We can discuss together if something in some across any discrepancies or deviation. We can come together. Another is the build of the application for releasing the quarterly, means if our application 10 builds, we'll get a 2 builds, so we can easily identify the bugs and easily to test the application.
Right. Yeah. So important difference
Waterfall.
between waterfall and agile is, like, testing will be started as soon as the coding is started, right? As soon as the project development is started, right?
Yeah.
So we are doing early testing in agile methodology. We are doing early testing, isn't it?
Yeah, correct.
Right. And once the testing is completed, of course, this is deployment phase, right? So now, so this waterfall model was replaced by agile methodology. So, however, if the requirements are understood in advance, right, or if it is a simple application, if it is a very small application, right, waterfall model is still being used, right? However, for medium to complex applications, enterprise applications, this model is not at all suitable because of the discussed drawbacks that we discussed now, right? Shall I move to the next slide, guys?
Yes, sir.
Yes.
Now let's understand what is meant by application architecture diagram, right? So application architecture means it is a pictorial representation of an application's components, software, and connections, right? Pictorial representation of the application's components. When I say components, servers, etc., right? Software and connections. So application architecture diagram helps us to understand how these servers or applications interact with each other to meet the business or user requirements. So let me go to the architecture diagram of a typical 3-tier application architecture. Okay. So here you go. So this is a typical 3-tier architecture of a 3-tier application. This is a traditional 3-tier architecture diagram. And now what does this diagram represent? It is a pictorial representation of different components, right? When I say components, what is the general meaning of component?
Elements, nothing but the website database.
Components means, no, what general meaning? I am asking, what is the general meaning of a component? Component means parts, right? Parts of something, small parts of something, right? So if you consider this application as an application, right? So what are the different components here that we have? We have web server, app server, database server, load balancer, and and different connections, right? Isn't it? Database connections. You'll have from app server to database server, you'll have DB connections and all this, right? So architecture diagram is nothing but it is a pictorial representation of an application component, server, software, and connections, right? And this architecture diagram helps us to understand how these applications interact with each other to meet the business or user requirements, how the software performs, right? That helps us to understand how these applications interact with each other to achieve the user requirement or the business requirement. Clear, guys?
Yeah, yes.
Yes.
Right? And the next important concept is, like, what is a server? Again, like, so one of the interview questions, so what is a server? When you say web server, app server, and database server, interviews ask, like, what is a server? What is a web server? What is a application server? What is a database server? Right? So server means it is a software or a computer program or a hardware. So we can call hardware also as a software, one box, right, on one computer, that is called as a server, or we can call software also as a server. Let's say, for example, we have Tomcat server. We call that, Tomcat is an application server, right? MySQL, Oracle, these are database servers, right? So when you say what is a server, when someone asks you what is a server, what is the apt answer? A server is a software or a computer program or hardware which understands your request and process your request and sends back the response. isn't it? Server is a software or a computer program or a hardware which understands your request, process your request, and sends back the response. Yes or no?
Yeah.
Right? Yeah. Now let's move. Shall we move to the next slide, guys?
Yeah, sure.
Yes, sure.
So the reason why I included this slide is like in the interview slide, interviewers will ask you, can you explain your application architecture? Can you draw the application, your application architecture diagram, and can you explain that, right? So you should know first what is meant by application architecture, what are the servers, what is a web app and DB server for your application, right? You should be having a knowledge of that, idea of those details. Okay. Now, this is a traditional three-tier architecture. Before coming to this, first let me explain two-tier versus three-tier architecture, two-tier applications versus three-tier architecture applications. Or else, we have something called, thick client versus thin clients. Let me. One more important concept or basics that you need to understand is what is thick client application and what is thin client application. Client application versus thin client. Okay. Or else, thin client, we can call that as this falls under three-tier architecture, and this falls under two-tier architecture. So or else all the browser-based applications are called as thin client applications, right? And all the desktop applications are called as thin client applications, isn't it? Desktop versus browser-based application.
Sir, I don't know about this thick client and thin client. Can you just explain me once?
Okay. So how did you join Zoom meeting today?
Like with a desktop application.
All right. You installed Zoom meeting on your machine and you joined through that, right? That means
Yeah.
you are using a desktop application or a thick client application. Why it is called thick client is it will take more CPU and memory on your machine. Okay.
Oh, okay.
That's
Okay.
the reason it is called as thick client. It takes more CPU and more memory. Whereas browser-based applications, right? So you need not install anything for a particular thing, for a particular application. Let's say if you are using ICICIbank.com, right? So you don't install anything particularly for that. You use a normal browser, which is which is used for accessing any browser-based application, isn't it? Any web application, isn't it?
Yeah.
So it consumes less CPU and less memory on your machine. That's why it is called as a thin client, right? So all the browser-based applications or web applications, they are called as thin client applications, and all the desktop applications are called as thick client applications. Clear?
Yeah, clear.
And also, like these desktop applications are called, they fall under two-tier architecture. So let me go to the PPT. So you install some client on your machine. So if you consider Zoom meeting, right? So Zoom meeting can be like you can join. 1 second. So you can join Zoom meeting through a browser as well as through a client, right? When you install client on your machine, right? So the client may be, of course, it may be developed in C++ or .NET or Java or any other programming language, right? So it will communicate directly with the server. It will communicate directly with the server. So whereas if you are using if you join Zoom from a browser, right? So you will be using some browser like IE or Chrome or Firefox. So it will communicate with your application server, and then that will communicate with your database server. So we have 3 tiers here, right? Whereas here, like you have a client and a server, right?
Yeah,
These are also called as client server applications. Okay. Yes. And all the browser-based applications fall under this 3-tier architecture. All right. And these are called as desktop applications, and these are called as browser applications, browser-based applications, or thin client applications. Clear, guys?
Yes.
So these are the different types of applications, right? And now I think I explained this, right? So if you consider any web application, right? So this is the most common architecture that is widely deployed, and it is gold standard developed as a result of web revolution. I got this from some. This is actually an image from internet, guys. Okay, so if you consider any web application, browser-based application, you will be using, different users will be using different browsers, isn't it? Right? And your request will first go to using any of these browsers. You send a request to the server, and your request will first go to the web server, right? And if your request is for a static content, I think I already explained this one, right? Did I explain this? What is static content? What is dynamic content?
I think on the second class.
Yes. So I think I generally use this example. I used to give this Gmail example. Suppose you type gmail.com, right? So everyone will get this page, right? Which is a static page, isn't it? The first time you access Gmail, right? So you get this page, right? Everyone get this page, which is a static page, right? This page doesn't change from user to user, isn't it? Or else if you use ircdc.co.in, every user gets this page, isn't it?
Yes.
Yes or no?
Yeah.
And this is a static page. There won't be much changes in this page, isn't it?
Yes.
Right?
Yeah.
Or else, Amazon or Flipkart or any other application. So actually, if your request is for a static page like this, right? These static pages will be served by web server itself directly. Means your request go to the web server will return that page, whether you use google.co.in or gmail.com or irctc, right? Or redbus or hdfcbank.com. The first pages, home pages, right? They will be served by the web server. As long as it is a static page, they will be served by web server directly, right? However, so what do you do next? Let's say, once you are on this page, right? You may be searching for some trains between some, any two different cities, isn't it? Let's say you are searching for trains between Hyderabad to Bangalore, right? And if you click on search, right? And now, what kind of page is this? Is it a static content page or a dynamic content page?
Dynamic content page.
This is the dynamic content, right? So,
Yes.
because it will show you the availability and all, isn't it? It will show you how many tickets are available and all this. What is the ticket cost and all this, isn't it? Yes or no? So it will show you the ticket cost and availability and all these details, right? So this is, and this content changes every time. This is a dynamic content page, isn't it? Now, all these dynamic pages will not be served by the web server, but your request will now go to the application server. Suppose you search for trains between two stations, or if you search for a product on Amazon or Flipkart, any other e-commerce applications like this, right? Your request will then go to the application server. Only static content will be served by the web server, right? If your request involves some dynamic content, so that request will go to the application server, and application server, if required, if it needs to get some data, right? It will establish a connection with the database, and it will run some query and get the query results, and it will send the results to the web server, and web server will send the results to the response to the browser, isn't it? So whenever they're able to follow everyone,
Yes.
Yes.
you understood what is the difference between static content and dynamic content that I'm speaking about, right? Yes or no? Suppose you type amazon.in, right? So this, of course, this page changes. Okay, I think this is not a right example, but you can take this one as some good examples, right? Suppose, see, once you type redbus.in, right? This page doesn't change every time, isn't it?
Normally,
this page doesn't contain any dynamic content, right? At least.
Yeah.
But but if you search for some, buses between two cities, isn't it? Then that content is the dynamic content, yes or no?
Yes. Yes, correct.
So this particular home page, right? This will be written by web server itself. This particular home page of Redbus application, this will be served by the web server itself, right? And however, so if you search for some, cities, some buses between two cities, right? Now, this content will not be available with this application, isn't it? With the web server. Web server, cannot serve this. Hold on, guys. Sorry, guys. This is also not not a right example. Sorry for that. Okay. I'll take, actually this works on REST API actually. Redbus application works on REST API. So I'll take one more example. I think you are in Bangalore, right? You are, where is this QO box, right? Yes, it's Bangalore based company, right?
Chennai.
Chennai. Okay. So, okay. Let's say I will take KSRTC example. Okay. And some user wants to book a ticket from Bangalore to Chennai, right? So this is the home page of the application, right? And like this page, or this is a static page, isn't it? This is a static page, and the content doesn't change very frequently, isn't it? So, and now this will be served by the web server itself. When you send a request to this ksrtc.in, right? This content will be served by the web server itself. So, however, if you search for some buses between two cities, right? Let's say, for example, you are searching buses from Bangalore to Chennai or Chennai to Bangalore, right? Now, this content, this is a dynamic content page, right?
Yes.
These timings will be changing, availability will be changing, ticket cost will be changing, isn't it? Right? So now what happens is when you do a search like this, search operation like this, right? Your request will go to the application server, and all these details, right? Ticket cost and availability and all will be stored in the database in some tables. And your application server also, like, it cannot serve your, it cannot respond to you directly. So it will it has to run some SQL query on the database, and it should get some data from the DB tables, and it will send that response to web server. Web server sends the response to the browser, right? Clear, guys? And now that is why, like, this is called as presentation tier. So whatever response you get from the application, right, that will be coming from web server itself. That's why this is called as presentation tier. And if there is some logic involved, if there is some processing involved, right, so that will be done at the application server level, right? And all the data will be stored in the database. That's why it is called as persistence tier. The data persists. The data will be stored in the database. That's why this is called as persistence tier, right? Now we understood this 3-tier architecture, guys. And what is the purpose of each of them? Web server, application server, and database server.
Yeah. Yes.
Yes.
So I'll take a pause here. One second. Right. So these are the popular web app and database servers in the market. Okay. So web servers, coming to web servers, right? Apache HTTP is the most popular web server with 40% market share. And Nginx is next, comes with the 23% market share. Okay. And HDFC net banking application and IRCTC use this Nginx as their web server. Okay. So this HDFC and IRCTC use Nginx as the web server. Apart from that, as this is an open source, right, most of the applications use this Apache HTTP as their web server. And these are the popular application servers. You have Apache Tomcat, Oracle WebLogic, WebSphere, JBoss, Pramati, and Microsoft IIS. These are the popular application servers. Okay. Actually, WebLogic was developed by a company called BEA, and it was later acquired by Oracle. So now that's why it is called as Oracle WebLogic. Initially, it was called as BEA WebLogic. Okay. And WebSphere application service developed by IBM. That's why it is called as IBM WebSphere. And Pramati is a now Indian-based company. I think it's a Hyderabad-based company, I believe. Pramati Technologies, a company called Pramati Technologies developed this application server called Pramati. Right? So this is an application server. And these are the popular database servers: Oracle, MySQL, Microsoft SQL, right? IBM DB2, MongoDB, SAP HANA, and all this. These are the popular database servers. Okay. So once the scripting is completed, and once before we start test executions, right? We will revisit these slides. We'll come back to these slides, guys. And we will discuss what are the different web app and DB servers, how to monitor them, and all those. Right? We'll come to that. Now, so let us, let's understand this application architecture in detail. Now, so I named this as, this is traditional 3-tier architecture, and I named this as new n-tier architecture. So why? Because so previously we used to have only web applications, like we used everyone used to access the web applications from a browser only, isn't it? Web browser, and the layout looks something like this. But nowadays, like we have, like most of the applications are being accessed using mobile browser, right? We can access the mobile browsers, right? We can access the applications from mobile browsers as well, isn't it? And the layout will be something like this, right? Isn't it?
Yeah.
Right. And now let's understand the internals of this, each of these layer. So if you take presentation layer, right? The first one we discussed that this is presentation layer, right? So that presentation layer, or whatever you see in a browser, whatever you see in a browser when you access any web on any application, right? So the Amazon or Flipkart or IRCTC or any application, right? So the presentation layer will be generally made up of developed using HTML, CSS, and JavaScript. Of course, there are a lot of new technologies now. We have Angular JS and a lot of other new things came into market. Yes. Someone is saying something.
Yeah, I'm saying React JS, Vue.js.
React JS, Angular JS. Yeah, you have all this nowadays, right? So presentation layer will be made up of this HTML, CSS, and JavaScript mostly, right?
Yes.
Again, React JS and Angular JS, they are based on JavaScript. Sorry guys, I'm not good in development.
Those are the frameworks.
Those are the
Angular
frameworks, right? Now let's understand like what is HTML and what is CSS and JavaScript. Okay, so in presentation layer, right? So HTML stands for, first of all, HTML stands for
hypertext markup language.
hypertext markup language, right? It is the language used for developing web applications, isn't it? So let me quickly show you. Let's check some websites. Okay. So if you right click and view source, right? View page source, right? So you can see that like all these web applications are developed using HTML language. You can see here doc type is HTML, means document type is HTML, isn't it? So this is the HTML code of that page, of that apple.com website homepage, isn't it?
Yes.
So this is the HTML content, right? Or the document type is HTML, right? So, right? And what is CSS in this? This presentation layer, right?
Cascading style sheet.
Right. So CSS stands for cascading style sheet. Yes. And what is the purpose of CSS file?
To enhance the HTML code.
Right. To enhance the HTML code, or CSS files are used to define the layout of the page, isn't it? Yes. Add colors to the page, or add colors to the background. All these, right? So this button should be green color or something like that. So all the or let's say if you take this particular slides, right? So we have this share button on the top, right? And we have the Google Meet and the over here, right? And this is the background color. For example, if you see share button, right, it has a yellow color background. So all these layout and colors and all background colors and all these will be defined in CSS files. Basically, layout will be defined in CSS files, isn't it?
Yes.
Right? So colors and all, I think that will be defined in HTML itself. You have something called BG color, background color, right? In HTML, there is a tag called BG, right? So BG color for background color, isn't it? So CSS is the main purpose of CSS file is to define the layout of any page. Define the layout. Let's say if you take this example, right? If you take this example, right? So you should have on the top, you should have a different links to different pages with a color background, right? And then you have different images over here. So all this layout will be defined in a CSS file. Clear, guys? Or if you take Gmail example, or Gmail example, right? So you should see the Gmail logo on the top left, right? All this layout will be defined in the CSS file. Or you should see a create an account button on the right side in blue color background, and you should have a sign in option over here. So all this layout will be defined in CSS files. Clear, guys? And what is the purpose of JavaScript?
Validations, client-side validations.
Right. So JavaScript, main purpose of JavaScript is for client-side validations, right? Client-side validations and client-side manipulations, data manipulations, and all will be defined in a JavaScript file, right? We'll understand going forward, like what is meant by client-side validations and all. Okay. Or else let me give some quick examples. So let's say you are trying to log in, and you are supposed to enter email or phone number here, isn't it? Suppose if I enter my email ID correctly, this is a valid email address, perftest.kb, right? So at gmail.com, or else this is optional actually. You can use at gmail.com, or if you don't even use that also, it will automatically take it. You got it, right? Even though you don't type @gmail.com, at gmail.com, it automatically took that, isn't it? So if you enter a valid address, right, valid email address, right, so it will take you to the next page. So on the contrary, on the other side, if you enter some junk characters like this, right, some junk characters like this, right, and if you click on next, right, it will display some error like this, right?
Yeah.
Right. Will the request go to the server? Will this whatever string that I entered, right? So that will be validated on the browser itself, right? It will not go to your Gmail servers. It need not go to your Gmail servers, right? So this is called as client-side validation or browser-side validation. This validation, whether it is a valid email or phone number, that validation will be done by some JavaScript code. Clear, guys? Everyone?
Yes.
So this is called as client-side validation, right? And JavaScript main purpose is to do that client-side validations or browser-side validations, right? That's the reason why you should know all these is, once you start scripting, right, you will see .css, .java, JS, and all these files, .html and all. So that's the reason you should know these basics. Okay. Now coming to the logic layer or application layer, or logic tier. This is also called as logic tier or application tier. So that can be developed in any of these programming languages like Java, .NET, or Python, or PHP, and all those, right? So this logic layer can be developed using any of these programming languages. Okay. The next layer is database layer or persistence tier, right? This persistence called as database layer or persistence tier. So, and like this database can be anything out of this, like it can be MySQL database or PostgreSQL, Oracle database, or Microsoft SQL Server, and all this, right? So this is the typical N-tier architecture. Clear, guys?
Yes.
Yes.
I'll stop it here, guys, for today. Yeah, so I'll stop it here, guys, for today. So tomorrow we will start the performance testing life cycle, right? And I'll explain what is RFI and RFP. This is from where, till now, whatever we discussed till now, these are all basics, right? Basics of computers, basics of testing life cycle or development life cycle, and all this. Now, like, we are going to start the performance testing life cycle concepts from tomorrow onwards. So tomorrow I'll cover like RFI and RFP and requirement gathering. I'll start requirement gathering. I'll explain what is meant by requirement gathering and what are the different non-functional requirements that we need to gather to start a performance testing project. And then in the next session, I will explain test plan document and what are the components of a test plan, right? So 2 more sessions for requirement gathering, RFI and RFP, and requirement gathering, 2 more sessions. 1 session for test plan document and its components, 3 sessions. Then after, like, we will start scripting. All right.
Yeah.
Okay. So after 3 to 4 more sessions, so I will start scripting with JMeter. Right?
Yeah.
Yeah.